Welcome to online classes. I am Shilpa, lecturer in computer engineering, working at Dr. B.R. Ambedkar, GMR Polytechnic, Karimnagar. In previous lecture, we discussed copy constructor. What is the use of copy constructor? What it do, and what is mean by dynamic constructor. Even we discussed how a particular program may consist of multiple constructors and some example programs we executed. In today's lecture, we are going to discuss what is meant by destructor, and we will see the uses of destructor with example program. And after that, we try to understand the concept of operator overloading, and we'll know that is we will list C++ overloadable operators, and also we discuss what are the different types of operators which cannot be overloaded. Okay, and if that permits, we will see how we can overload a unary operators. And in today's lecture, what is meant by destructor? Destructor is used to destroy the memory which is constructed by the constructor. It is used to destroy the objects that the constructor had created. Okay, so normally by using the object, we try to create or allocate memory for the objects, the data members of that particular object. So when we are not using the particular object, or when we are running out of its scope of the object, then the memory which is allocated for that uh, object should be destroyed, because the memory anyhow we are not using the object, that means the values which are assigned to this object to the data members. So what is the need of storing those values in the memory? That's why when we are running out of the scope of the object, it is better to destroy or deallocate the memory which is allocated for that object. So of course we can do those using dynamic memory allocation, deallocation, that is using delete. But here we are having another concept, that is destructor. Destructor simply destroys the memory which is allocated for the objects at the time of construction call. And a class have another special member function called the destructor, which is invoked when an object is destroyed. So here the destructor is also a special member function like constructor. Okay, constructor which constructs the object, and destroy which destroys the object. So these two are special member functions only. And of course the name of this destructor is same as the name of the class, except that it is preceded by the till operator, till symbol. So like constructor, the name of the destructor is also same as the name of the class, but except what, the name should be followed by preceded by till operator. Okay, this is only the thing we need to remember, that is the name of the destructor is same as the name of the class like constructor only, but here the name of this destructor preceded by the till operator. And here similar to constructors, destructors must be declared in the public section of the Similar to constructors, destructors must be declared in the public section of the class so that it is accessible to all its users. Because here when we are declaring the constructor, also one thing we need to remember, that should be declared in the public. If you are not declared in the public, and if you declared either in private or protected, of course protected will be in inheritance concept, we will discuss that. So if the constructor or destructor is declared in private section, then the private data cannot be accessed out of the class. So always the constructor and destructor must be declared in public section of the class only. And destructors have no return type, not even void. As the constructors not having any return type, here the destructors also not having any return type. Almost all the characteristics of constructor comes to the destructor, only the name preceded by till operator. That is the added one. That's it. There cannot be more than one destructor in a class. Normally, when we are creating constructors, a program may consist of any number of constructors. That's why we call program with multiple constructors. Default constructor, parameterized constructor, and copy constructor can be in a same program. But here we don't have more than one destructor, because the purpose of destructor is to simply destroy the memory created for the object. So no need of any different types of destructors like constructors. That's why here there cannot be more than one destructor in a class. And unlike constructors that can have parameters, destructors do not allow any parameters. Okay, here it is not allowing any parameters, it is having only default destructor, and they do not have any return type, just like constructors, not even void. And when you do not specify any destructor in a class, compiler generates a default constructor and inserts it into your, that is our code. So if you are not specified any destructor in our program, then the compiler generates a default constructor and inserts that default constructor in our code, like default constructor. This is destructor, and like the default constructor, if you are not specified any default any constructor, then the compiler only creates the default constructor for that particular program that internally inserts that into the code. Likewise here, when we are not yet specified any destructor in a class, then the compiler generates a default constructor and inserts that into our code. So the syntax of the destructor is, because here always the name of the destructor is same as the name of the class name only, but preceded by till operator. So this is the syntax of destructor. So class, here the name of the class is dest demo, destructor demo, private section, and always the constructors and destructors should be in public section of the program. That's why here dest demo, that is the constructor. Okay, and this is the destructor dest demo. Okay, the both the constructor name and the destructor name is same, but here the destructor followed the till operator, preceded by the till operator. So this is the syntax in order to declare the destructor. Class name, that class name should be used as the member function name preceded by till operator. Then we can say this is the destructor. And now we'll see one example program for destructor. So as all of us know, normally in programming languages we start with hello world program. So likewise here we are having the class hello world, and in public section one special member function, that is constructor. How I can say this is a constructor? Because here the name of this is same as the name of the class name. So I can say this is the constructor. And in that I am writing only cout constructor is called. Constructor is called. That's it. And one destructor, how I can say this is a destructor? Because here the name of the function is same as the name of the class and it is preceded by till operator. So I can say this is the destructor. And the body of the destructor is called. That's it. And one member function, that is display, and here what it do, simply displays hello world. So that is, here in our program we are having three member functions. Among these three member functions, two are special member functions. So here one is constructor, one is destructor, and one is special member function. All these are doing only a single, those are having only a single output statement. That is constructor is called, destructor is called, and hello world. That's it. And in main, we are creating object for the class hello world, and using that object we are calling or invoking the member function display. So as all of us know, we need not to call the constructor using the object. Only at the time of creating object for the class, it automatically invokes the constructor. So we are not at all called the constructor function, that is hello world, using object. We call only the member function display using the object. Now we'll go to our one. So key is not working here, so for that I need to no, we'll execute the program. Now let us open Turbo C++ and we will execute this program. Hash include IO string, hash include IO string, hash include conio, and define the class hello world level, and with three member functions declared in public section. One is constructor hello world, and simply one statement cout constructor call constructor call and end of the constructor and destructor hello world, and here it is having only single statement. Destructor is called end of the destructor, and one member function void display cout hello world. So here why I am writing all these member functions instead of only having a single uh, statement, because here we need to know the differences. Okay, that is automatically here when we coming out of the scope of the object, it destroys the object. So in order to check that, here we are specifying, of course, without the constructor the memory cannot be destroyed by the destructor. So we require one constructor and we require one destructor, and in order to show we need not to call the either constructor or destructor using the object. Here we are declared another special, that is member function, that is display, and end of the class. Now write the main int main create object hello world create object hro and using that object simply call the member function that is display and get ch and return 0 return 0 return 0 alt f save destructor run the program compile the program yes, expected zero id display nendel alt f save compile run the program see constructor called hello world and destructor is actually has to okay otherwise let me make that into the that is group here I don't have alt F5 keys are not working that's why normally we should get destructor call as output compile the, run the program destructor is called constructor called hello world destructor is called even in previous okay previous also we got destructor is called okay this is the output of the program though we called only that is display go.display it is calling constructor as well as the destructor before that is before calling this member function it is invoking constructor definition and after executing that particular one that is before the end of the object it is calling the destructor function and that's why we are getting this as the output here in main we are simply calling object go.display but before that when we create the object it is invoking the constructor function so that's why we are getting constructor call and o.display so it is calling display member function so here we are getting hello world as the second statement in the output and as here we are going out of the scope of this object because here the scope of this object is within this block only so as we are going out of the scope of this object go, it invokes the destructor. That's why we have got destructor is called. This is the example program for destructor. Of course, we will see one more example program on destructor. So here each and every time it simply counts the number of objects created. That means how it will calculate the number of objects created because each and every time when it creates an object it invokes the constructor. So here we will use one count in constructor's body and there we simply using that count we can able to know the number of objects created for the object and also in destructor we use one count that is it reduces when a particular object is going out of its scope so that we can know which object was deleted or destroyed, like that. Here we are having one program. So here we are declaring one variable count and initialized to 0, and one class test, and it is having one constructor. In that, simply it increments the count and displaying count cout constructor. The value of this particular count is created. For the first time, constructor 1 is created. If we create one more object, then if it invokes the constructor, then we will get constructor 2 is created. Constructor 3 is created. Likewise, we will get the value, that is the number of objects created for the class. Okay, that is by simply increment the count value. And we are defining one destructor, and here we are simply writing one output statement. This is also cout. One output statement destructor. This particular count is destroyed. So as that count, the object is destroyed, we need to decrease the value of the count. That's why count minus minus. And in main, simply we are first cout inside the main. Sending this inside the main as the to the output screen, and creating first object t1. So here we created object t1, test t1. Okay, and after that we open one block. So in this block, that is I am saying this block as block 1, cout inside block 1, and cout creating two more objects, that is t2 and t3 for the class test. Okay, I created two more objects here, and cout leaving block 1, that's it, and cout block inside the main or enter into the main, can return 0. So now we will simply here what we are doing, we are declared one class test with one constructor and destructor, one count value. So we will check whether when we create an object, whether it invokes the constructor or not, and when our program is going out of the scope of the objects the destructors were called or not. Okay, so for that here we define one class. Okay, now let us open this and write the program. Save as destructor 1 dot cpp. So now I want to change to this particular one. So before that I am declaring globally one variable int count and assigning to initially 0, and class test and in public the name of that should be same as the name of the class. So test c count, then whenever the constructor is invoked, the count value should be incremented count plus plus, and cout constructor count is called. That's it. And destructor test, and here destructor count is destroyed okay, and if the object is destroyed, then the count of the number of objects should be decreased. So count minus minus, right? And That is the end of the class. Simply one class test with that is constructor and one destructor. Constructor increments the count and it is displaying that count as constructor is called, and destructor simply displaying destructor count is destroyed and count minus minus decrementing the value. Int main, and in main cout cout inside the main inside the main. Okay, and simply cout creating first object, that is P1. Creating first object T1. That is now create object T1. Okay, and now go to one block. Go to one block, and here cout inside the block 1. Block 1 inside block 1 and cout creating two more objects. T2 comma T3. Okay, now create objects test T2 comma T3. Now cout leaving block 1, leaving block 1, leaving block 1. Now cout block and turn into main. That is for our understanding purpose only. Okay, and let's ch return 0. Return 0. CLR CR. Okay. Now save the program, compile, save, compile, into main. The block was closed and 2 times. Okay, because we copied the. Okay, save, compile, run the program. Inside the main, creating first object T1, constructor 1 is called. Inside block 1, creating two more objects T2, T3. Constructor 2 is called, constructor 3 is called, leaving block 1, destructor 3 is destroyed, destructor 2 is destroyed, entered into main. Okay, and after that, even we will get destructor 1 is destroyed, because immediately here, as I have given get ch, it is not returning that thing. That's why here we are not getting, but we will get definitely here if you are having that is, in order to see the output without get ch, that is alt F5. Okay, you can able to see, but here in my system all the functional keys are not working. That's why I am unable to show you. But if I want to show you again, here I can make that into another that is a block for main also. Okay, now I will get, see, destructor one is destroyed. That is also we are getting here. Previously that get ch means it simply uh, that is get the values on the output screen without returning the object to the main function. Okay, that's why you are not getting there. So if you are having that is a total functioning system, then simply without having this another block, okay, without having this another block, you will definitely get the destructor uh, 1 is destroyed. Okay, like that. That is, in that case you don't need not to use this get ch. Okay, definitely you will get destructor 1 is destroyed. Okay, now operator overloading. So before going to operator overloading, um, what is meant by polymorphism? Polymorphism is the one which is having more than one form. Poly means many, morphisms means forms, many forms. That is, a single thing may have many forms. So in that only, that polymorphism can be divided into two types: compile time polymorphism and runtime polymorphism. And compile time polymorphism is again two types: function overloading and operator overloading. As we discussed, the function overloading as we are aware of the function overloading, here the name of the function is same, but the number and type of the arguments are differ. So by specifying or by referring the arguments, the compiler can distinguish the different definitions of the functions with same function name. Okay, that is, our program is having number of functions with same function name but with different prototype. That is function overloading. Likewise, here we are having operator overloading. So operator overloading means here the same operator is having different meanings at different situations. For example, if I want to add two integers 10 plus 20, that is 30, the result will be 30. That means here what it is plus is doing, it is simply adding the values, that is two integers 10 and 20. And if I want to add two strings oops through, that is one string plus C++, that is another string. So when I use this plus symbol on these two different strings, obviously here the meaning of the plus will be changed, in that it adds two integers. But here when we are trying to add two strings, that is difficult to add. Here even the meaning of plus is here not adding. The meaning of plus is not here, not adding. In previous example 10 plus 20, there the meaning of plus is adding these two numbers. Add those two numbers. But when we are using this plus on two strings, here the meaning of plus is not adding. Append the second string at the end of the first string. The meaning of plus in this case is add second string at the end of the first string. That means here the same plus is behaving differently in different situations. First one is adding, second one is appending. That means here the same existing operator plus is having more than one meaning. More than one meaning. That is nothing but overloading operator, because plus is a operator. So that is called as operator overloading. The mechanism of giving special meanings to existing operators is known as operator overloading. Plus is existing operator which adds two integers. But here we are trying to provide another meaning for the same place to add two strings. That means append the second string at the end of the first string. Okay, that is not same as the addition. Okay, so we are providing another meaning for the existing operator. So that concept is called as operator overloading. The mechanism of giving special meanings to existing operators is known as operator overloading. And here, this operator overloading is one of the many existing features of C++, and it enhances the power of extensibility of C++ and provides a flexible option for the creation of new definitions for most of the C++ operators. So here what this operator overloading is doing, it is creating new definitions. Already all the C++ operators are having their own meaning. But here this operator overloading creates a new definitions or new meanings for already existing operators of C++. Okay? And it facilitates the creation of a new language. And this is a way to implement polymorphism. Operator overloading is a way to implement polymorphism. And this polymorphism is also known as static binding, early binding, or compile time polymorphism. As we discussed, polymorphism is two types: compile time and runtime. Compile time is again function overloading and operator overloading. So this operator overloading is a way of implement polymorphism, and that is called as operator overloading is called as static binding, early binding, or compile time polymorphism. That is a way of, that is a one method of static binding, early binding, or compile time polymorphism. And this operating overloading is done with the help of a special function which must be either a member function or a friend function. So how we can overload a operator? And this operator overloading is done with a special function. Okay, using a special function. That is, if you want to use this operator overloading, or if you want to specify a or define a operator overloading, then you need to declare a special function, and this special function may be a member function or a friend function. Okay, because here the member function, friend function can access the private data of a class. Okay, so when if you want to declare a operator overloading function, then first we need to declare a special function that may be a member function or a friend function. And here operator overloading extends the semantics of an operator. So normally here semantics means meanings. Semantic means meanings of an operator. It extends the meaning of an operator. Normally plus is having some meaning, but when we are overloading this plus, simply we are extending the meaning of that operator. We are providing one another meaning for already existing operator. So here operator overloading extends the semantics of an operator, and it does not change the syntax of an operator. So it simply extends the semantics or meanings of the operator, but it will not change the syntax of the operator. Always the plus means plus only. The sign like this only, plus. It is not changing its syntax, and the plus should be with either that is in this case plus. That's why that operator should have at least two operands. If that is unary operators, at least one operand. Okay, the syntax is same as normal operators. Okay, only the semantics of that operator is changing. It does not change the syntax of an operator, such as number of operands, precedence, and associativity of the operators are not changed in operator overloading. An overloaded operator should not change its original meaning. So when we are overloading the operator, that overloading of operator should not change its original meaning. Always plus means adding two numbers, that's it. Okay, we are providing another meaning for plus, but we are not changing the existing original meaning of plus. Clear? Overloaded operator should not change its original meaning. And one of the operands must be an instance of a class. So when we are overloading an operator, so always the operator should have operator operates on operands. Operator perform operations on operand. Okay, so here when we are trying to use this operator overloading, one of the operands must be an object. That thing we need to remember throughout this operator overloading. That is, operator performs operations on operand. Operand. So here, if that is unary operator, that operand should be object. If that is binary, then at least one operand should be object. If that is ternary, then at least one operand should be object. That means here one of the operands must be an object in operator overloading. When we are trying to provide another meaning for already existing operator, here one thing we need to remember is we are providing another meaning for already existing operator, but we are not at all changing its syntax. Of course, we are not at all changing its original meaning, and one of the operand must be an instance of a class, that is object. And of course, all the operators are not overloadable. In C++, we are having some set of operators, but all the operators are not overloadable. There are some operators which cannot be overloadable. Okay, so here the key points for this operator overloading is it simply extends the meaning of the existing operator. It provides a new definition. Okay, and that should be a special function, that may be a member function or friend function, and it's simply changing or providing another meaning for already existing operator, and it is not at all changing its original meaning or its syntax. And always one of the operands must be an instance of a class. If that is a unary operator, then the operand is an object. No option, is an object. If that is binary operator, then the one of these two should be one object. And if that is ternary, then among these three, one operand must be an object. And all operators are not overloadable. So now we'll see what are the different operators that can be overloadable. Okay, so here as we are having that is types of operators all of us aware of types of operators. So almost all the operators, that is arithmetic operators, bitwise operators, logical operators, relational operators, assignment or initialization operator, and arithmetic assignment operators or shorthand assignment operators, and even shift, left shift, right shift, left shift equals to right shift equals to, okay, and unary operators, subscripting operators, function call operators, and dereferencing operator, unary sign prefix operators, and allocate and free, that is new and delete. All these operators are overloadable operators. Overloadable operators, that means almost all the that is, we can overload almost all the operators of C++, almost all the operators of C++, arithmetic, bitwise, logical, relational, assignment, arithmetic assignment or shorthand assignment, and shift, unary, subscripting, function call, dereferencing, unary sign, and new and delete. All these operators can be overloaded. But there are some operators which cannot be overloaded. There are some operators which cannot be overloaded. So these are the main operators, that is four main operators which cannot be overloaded. That is class member access operator, that is dot, class member access operators dot comma dot star, period operator, and scope resolution operator, we cannot overload this, and size of operator, size of, and conditional operator or ternary operator, question mark colon. These operators cannot be overloaded. These operators cannot be overloaded, and except these 4 or 5 operators, almost all the operators of C++ can be overloaded. Clear? So this is the on here we will wind the lecture. So in today's lecture we discussed what is destructor, what are the different types of destructors, sorry, what is the destructor, and with the example program we have seen the destructor is simply destroys, and a program should consist of only one destructor. And after that, operator overloading, what is mean by operator overloading, what are the key points of operator overloading, and we will discuss overloadable operators and the operators which cannot be overloaded, and we will continue in the next class.